A very good morning, children. Welcome back to the next session on force and pressure. In the last session, we studied about contact and non-contact forces and its examples. Today, let us learn about pressure and pressure exerted by liquids. When you hammer an iron nail, you apply the force on the flat side of the nail and the pointed side of the nail which is in contact with the wall then applies the force on the wall and tries to pierce it. If you can observe, the hammer is just pushing the flat side of the nail and the pointed end of the nail is piercing the wall. Now, let me ask you an interesting question. What will happen if you hammer the pointed side of a nail and tries to pierce it with the flat surface? You will find it very difficult, isn't it, children, to push this nail through the pointed surface, whereas the flat surface has to pierce the wall. What is the reason for this? The reason is that the pressure applied by the tip of the nail on the wall is more than the pressure applied by the nail flat surface. But the question is why? First, notice the area of the tip of the nail is very less when compared to the area of the flat surface. This tells us that the area of the surface on which the force is applied is important. We will understand it in detail, but first of all, let us define pressure. We define pressure as the perpendicular force acting on the surface of an object per unit area on which it is acting. Simply, I can say it is force which is acting in unit area. We already know the SI unit of force, children. What is it? SI unit of force is Newton, which is denoted by N, and that of area is meter square. If the force is having SI unit of Newton and area is having meter square, then what will be the SI unit of pressure? SI unit of pressure is Newton per meter square. It is also called as Pascal, which is denoted as PA. Why it is called Pascal, children? It is given this name to honor the achievements of a French scientist named as Blaise Pascal for his contributions in hydrostatics and hydrodynamics. Observe the equations carefully, children. As I've said, pressure is equal to force divided by area. Okay. Now, just consider the force applied as a constant value. Then change the area in order to say increase the area. Then just to see whether the pressure will increase or decrease. Let us understand this by mathematical example. Here I have taken 4 fractions. In all the 4 fractions, numerator I have kept constant. In other sense, I can say numerator is nothing but the force applied. I have put the force applied to be constant. Say it is 3 Newton. Whereas area I have increased from case to case. See, in the first case I have taken area as 5. Next case it will be 6 meter square. Third case it is 7 meter square. And fourth case it is 8 meter square. When I increase the area, just to see the value of the fraction what you are getting. In the first case it was 0.6. In the next case it became 0.5. And in the third case it became 0.43. And fourth case it became 0.37. What do you observe from all these values, children? You are observing that as the denominator increases, then the value of the fraction also decreases. That means as you increase the area, then the pressure decreases. Okay. So therefore, I can say increase in the pressure, increase in the area will decrease the pressure. Okay. Now let us go back to the first example what we took. In the first example, here we saw that the nail and the wall. Notice that we are applying force perpendicular to the surface of the wall. So, now what you are observing, children? The angle between the nail and the wall is 90 degree. If you notice the tip of the nail, has a very small area compared to the flat surface. If you consider, the flat surface area is more, whereas the tip is very lesser, and the area of contact is lesser, where in case of the you are hammering the flat surface, as it comes in contact with the wall, the area of contact is lesser and there will be more pressure. Whereas if you take the case of a hammering a nail which is towards the pointed size, here the pressure is lesser because the flat surface of the nail is in contact with the wall. That means the area of contact of the nail is more in this case. Therefore, the pressure what you are applying with the hammer is lesser. So therefore, the flat surface of the nail cannot pierce through the wall. Understood, children? Now, as we saw the example of hammering a nail, wooden blocks which are kept on the table also exerts pressure on the table. We know that wooden block is a solid substance. So then, what about the liquids, children? What about liquids? Do liquids or fluids exert pressure? So, we know that the liquids are kept in a container. So, if we consider whether they'll exert pressure, yes, they do. Now, if they do exert pressure, then how will they exert pressure? So they exert pressure on the base as well as on the walls of the container in which they are enclosed. The pressure on the base will be downward and the pressure on the walls of the container will be sideward. We'll notice an interesting things if we look at the fluids in terms of layers, children. So let us divide the fluids in different types of layers. Say the first layer, second layer, third layer, fourth layer and fifth layer. Let me take an example of this. If you divide the fluid into 5 equal parts, you can see that the second layer is holding the weight of the first layer. Likewise, the third layer is holding the weight of the second and the first, whereas the fourth layer is holding the weight of the first 3 layers. Likewise, I can say the fifth layer is holding the weight of the first 4 layers, and so on. So, you can clearly observe that the pressure at the bottommost layer is maximum since it is holding more of the weight. Whereas, just check, the topmost layer of the liquid is having a less pressure. Now, let us understand this by an experiment. So, what you have to do is, near the topmost layer, make a little hole at the side. You will see that the water flows out like this from that hole. It does not roll along the wall. It flows out with an angle. Now, let's make the second hole under the first hole. Just observe, children, what it is happening. You will notice that the water flows out at a wider angle when compared to the first one, isn't it? If we continue to make the holes in the wall, then we will notice that the water literally flows out or spreads out. This shows that the pressure at the bottom of the layer is more when compared to the pressure at the topmost layer. Okay. So now, by this example, it is understood that the pressure exerted at the bottommost layer is more because the water is coming out with a greater angle when compared to the water which is coming out from the topmost layer. So here the angle is lesser, whereas the bottom layer is having the more angle. Understood? Therefore, I can say the bottommost layer is having more pressure compared to the topmost layer. Then, what about the upward force exerted by the liquids, children? Let us Understand this by an example. So have you ever tried to drown a ball in water? If you have not tried it, try it, children. If you try it, you will find that the force is pushing it upward against your force. If you are pushing towards downwards, again you can feel some upward force which is exerted by water. That means the water is also applying upward force against your force, so that the ball will not sink in the water. So, we saw that the water can apply lateral pressure, then the downward pressure as well as upward pressure. So, I can conclude that the liquids exert pressure in all the directions, not only downward but also sideways but also upward. Liquids exert equal pressure at the same depth. Then the pressure exerted by the liquid increases with increase in the height of its column. As I've said, pressure at the bottommost layer will be more when compared to the pressure at the topmost layer. Understood, children? I hope you have understood the definition of pressure, and also you saw how the pressure is exerted by the liquid, so in the container, not only downwards but also in all the directions. It is the time now to take down the homework, children. So the first question is define pressure and write its SI unit. The second question is explain with an activity to show that liquids exert pressure. I hope you will write down this homework in your notebook as well as in your A4 sheet. So thank you for watching the class, children. Have a good day. Stay at home and be safe. So we will meet again. Until then, goodbye.